6. Let's figure out, what could go wrong? Kind of what's going on in section 7.3b. Go wrong. I mean, you're adding and subtracting and multiplying, and that could definitely go wrong, that's true. But what could go wrong if all of your math is right? Maybe wrong's not the right word, but what could go wonky? What could go weird? What could go differently than we expect? Well, here's one thing that's definitely different than we expect. What if there are not enough equations in the system? Then there will not be, there cannot be a unique solution 1x, 1y, 1z. It's impossible. But that does not mean that we can't still state a relationship between the answers. Just because we can't say there's only one point doesn't mean that we can't say anything. We still have two equations. They're still showing certain relationships between x, y, and z, and they're limiting the answers that are possible. Let z equal a. We say, you don't give me a third equation, I'll make my own. What I'm going to say is I cannot possibly narrow it down to one unique x, one unique y, one unique z. And since I cannot give you an x and give you a y and give you a z, it's impossible for me to get the bottom row of the stair step. It's impossible for me to get z equals 2, or z equals 0, or z equals anything. So I'm just going to say, fine, z equals something. And if z equals something, I wonder if I can figure out what x would be in terms of that something, and what y would be in terms of that something, based on the two equations. Yes. Follow your system. Technically, wouldn't our system have to say, this is one of those where the computer wouldn't know that the two are not multiples, or sorry, I would say the program wouldn't know that the two are multiples of each other. We could look at this and say, just multiply the top one all by -2. And that's the joy of having an actual person working on the problem, not having to have a computer do it. The computer would need to be able to say, I don't care what's there, I'm just going to say, this guy times -4, that guy times a +2, and let's just go. And then we cancel. That's okay. You guys are humans. Let's go ahead and use that to our benefit. Can we just make -4x minus... What I just do? Multiply everybody by a -2 and write it. That is okay. For the purpose of, let's go, 18 minus 6. Well, if it's impossible for me to get z equals a number, and we're using z equals a, don't we technically have enough to make a row echelon form right now? Because what does it take to have row echelon form again? Yeah, 3 equations, stair stepping down, with an x and a y and a z with a leading coefficient of 1. Oh well, gotta do what we gotta do. So, how on earth am I getting all these nasty decimals all of a sudden? Divide everybody by 2. Now, technically, if we were doing like the programmer put into our TI calculators, I think we realized yesterday they always take the bottom equation for whatever reason. So we could take the bottom one and divide everybody by 4. Yes. We could take the bottom one and divide everybody by 4. And be like the program, but I don't know. I wanted to divide by 2. Is that okay? Yeah, totally. I took the top equation, and I said for row echelon form we need a leading coefficient of 1. That's how the form works. So I had to divide everybody by 2. Does that make sense? So what am I going to do when I go to do then my, this is a struggle, my stair step? Divide everybody by? Ooh. 12. I need to get a leading coefficient of 1. So the only way to get 1, does that make sense? Divide everybody by 12. So 12y over 12 will just be 1y. 9 over 12, that reduces, right? 3/4. And then 30 over 12. 6 goes in, 5 over 2, right? 6 goes into 35 times, 6 goes into 12 2 times. 5 halves. And the bottom one, let z equals a. Now, some of you guys might be wondering why a programmer would get the row echelon form to have leading coefficients of 1, but do you guys remember the point of getting row echelon form? Why do we like the stair step? You can always plug in, and do you see how a computer wouldn't be afraid of fractions? And so if you could just tell it to, oh, plug in and subtract, oh, plug in and subtract. But you wouldn't have to do the extra step of dividing, so maybe it's just easier to program without having to have a number. And random. But how do we finish?
Plug in A.
The key was letting z equal a. You're like, fine, you didn't give me enough, well, I'll just say z is somebody. Well, if z is somebody, y has to be very special in relationship to that somebody. So let's figure out what that would be. If anybody looked at the answer to number 37, it was weird and it had a's. It was weird and it had a's. So y is going to equal, 5 over 2 minus 3 over 2a. Oh yeah, I'm silly, I didn't even read it. I was just assuming I remembered it. Okay, so now it's time for x. I know you don't like it, but it is what it is. You gotta go solve. So if you're like, well, I just wouldn't get a leading coefficient of 1. Well, that's okay. That's why you're not a programmer. But anyway, coming back. Remember, the goal isn't being able to solve this problem the quickest. The goal is being able to have a system that you can make a computer do for you for the future. Alright. Now it's time for x. So we have x plus, technically, if you want to be super snazzy, could you just say x is equal to and subtract those to the other side? So we could do 7 halves minus 3 halves times, alright, who's y? Here he is. 5 halves minus 3/4 a minus 3 halves z is a. What did I do? Well, I was lazy and I moved it all over. You could box it and be done. Technically, you're not wrong. In calculus for long answers, I would totally let you do that. In pre-cal, though, we need to check it in the back. We would end up with 7 halves minus 15/4. Let's get this guy to be a fourths also. So 14/4 minus 15/4 would be a negative 1/4. I have positive 9/8 a. 8ths. Okay, I want this guy to be an 8ths also. So let's multiply him by 4 over 4. So I have positive 9/8 a minus 12/8 a. 9 minus 12 is negative 3/8. So we got this guy, we got that guy, and now we got that guy. So how do we write this ugly and disgusting answer or solution for a non-square system? Just the way it shows. I realize it just got cold. Give me 1 second to go ahead and write this down. Pause. Grab your calculators and put in those two equations and be like, what would the calculator do? Ready, set, go. Let me try to turn down the air. Yeah. Yes, you. What will your calculator do? It doesn't even give you enough information. How are you going to do REF? It should turn off, so it's in here. right? You guys had to change the size of him, right? He just ended up being, what, a 2x4? Okay. So change him to be a 2x4. Uh-oh. Huh. All right, then what'd you guys do for REF1? Remember. Good, second matrix, then what? Then what? What number is that? Oh, that's annoying. Okay. There he is. Of matrix A. Ooh, what? What did this thing do? Can you guys tell what it did do? Now, I'm going to go, remember you can change it to a fraction, math frac. Looks a little nicer now. There he is. Why? Oh, hey. Pause, pause, pause. Does it have something kind of similar to mine? It has an X and a Y and a Z and a number, and it has a Y and a Z and a number, but what doesn't it have? Oh, it doesn't have the last one. And the reason why is because it didn't even know it could even look at a third one. So what if we were to do this, guys? What if we were to do second matrix? What if we were to make it a 3x4? Here's an interesting exercise that sometimes is helpful and sometimes is not. And what if we were just to make the last row 0? And say, well, we don't have anything. We want something, we just don't have it. 0, 0, 0, 0. Okay. Then we were to go ahead and try again. Let's see if it would like us any better. Was it able to do anything else? No. Reason being, they didn't give you enough to find Z. They didn't give you enough to find Z. But what can we do then? Just say Z equals something. The calculator can't do what we can. We can take what the calculator has. And that would skip this system part, but it can only get up to here because it can't possibly say, like, oh, you didn't give us Z? Fine, we'll make him a variable. I mean, I guess someone could program that in. Ask Jason Johnson, I bet he could. But Z equals A. We could have used it here and said, okay, hey, if Z equals A, let's plug it in, and 5 halves minus 3/4 A. Oh. Would be Y. Then guess what would happen if we plugged in Z as A and plugged in Y is for this equation, even though it looks differently. It's from an equivalent. It's from another source. And so therefore, we would have actually, as long as you knew let Z equal A, you could even use the calculator to get this exact same solution, which says, all right, I have no idea what Z is, because Z can be all sorts of different things. But if Z was A, if Z was, let's just say if Z was 1, I'd plug in 1, and that's Y, and that's X. If Z was 5, plug it in, I'd find Y, I'd find X. If Z was 4, plug it in, I'd get X, I'd get Y. So they give us what we call a non-square system. The reason being we have 3 unknowns but only 2 equations. What you have to remember, get out a highlighter, a colored pen, circle, star it. If you ever have a non-square system, let Z equal... Okay. There we go, I was waiting. So let's come back to our number 37. Did I get that? Yeah, I did. Because number 37, you might be like, I don't get the tie-in because 37 has 3 equations. For the 3 unknowns. But guys, what was the dilemma? Who was our Z? I don't know. We tried to get Z and we got 0 equals 0. What's true about 0 equals 0? Well, it's true. That's all we know. So guess what we're going to do for our stair step? There are 2 times we let Z equal A. We let Z equal A if we have a non-square system. We only have 2 equations with 3 unknowns, but we also let Z equal A if when we try to get our Z, we just get a true statement. We're like, okay, so Z can be anything? Exactly. Z can be anything. So how are we going to finish that? let's make our stair step. Now, the nice thing is we're not a computer, so can we choose this nice and easy one to be our first? Because it already has a 1, right? So let's use our x plus 2y minus z equals 5 to be our first. What do you guys want for your second? You only have 2 options to choose from. We need something with a y. This one? Okay, how do we get, can't we just divide everybody by -9? Cool. So divide by -9, we get y. Divide by -9. Divide by -9. How do we solve? Yeah. Ready, set, go. Vibrate your groups. Let's see if we can get it. You will get what we did, except when you're looking for the z, it would be 0, 0, 0. Alright, this one's a little prettier than the last one. I didn't think you did the fractiony one by yourself.
It's 2a minus a. Oh yeah, yeah.
My turn, can I play?
X plus 2y minus
You guys agree?
Yeah. Check them.
I only do that when I have people that can double check me. Anyway, we good? How many solutions are there? Infinitely many! But all on the plane? No. Specific enough. Yeah, specific. Kiddos, throw it in your graphing calculator. I just want you to see what it would look like. Because the last one, there were only 2 equations, and all I could do were the 2 rows. That kind of made sense. I even had you put in like a row of zeros, and it was still like, well, I can only give you the 2 because I can't tell you who z is. This one, you have all 3. It's a 3 by 4. Let's see what the calculator does as to what's going to happen that should clue you in if you were allowed to use your calculator to, ooh, this isn't normal. People who don't have a calculator be peeking at the person doing it, making sure you understand how to do it, where to go, what to type in.
I have a question on the answer.
Yeah.
So the x value, how did you get 3 minus 10?
I don't want to hear literally how I did it. So, in essence, I needed to plug in the 1 plus a minus a equals 5. I went ahead and distributed first and then subtracted. So 5 minus 2 got me the 3. Then I had 2a minus a. And then that's 1a and I subtracted. So easy to make a mistake. Just watch out. Okay, I think I made like 3 mistakes before I finally got to the 3 minus a. What happened? What did it do? What's the bottom row? What? Exactly. What could it not do? Couldn't find z, and that was the point. Your calculator could not find z. It was an impossible, complete row echelon form. So if your calculator ever does that, now you know what's going on. It's not that there are no answers. The problem is there's infinitely many answers, so you can't just say one. It's not going to work. So then what do we do if you ever get a true statement going for z? What? Z equal? Number 37 make a little more sense now? Okay. Alright. Here's something else funny that might come up. In section 7.3b homework, it shouldn't have come up in A. What if they give us man, my voice is not happy today. What if they give us in the directions this equation? And P.S. I have you write the directions because there is very commonly very important stuff in there. Whether it's vocab, whether it's directions, whether it's a random piece of information you wouldn't know to use unless you read it and wrote it down. I'm going to show you guys in the actual book in just a second, but for right now, get ready for example 48, which I bet you have one similar in 7.3b homework. Doing all right, bud?
Yeah.
See me in there. Okay, we have it. Multiple unknown quantities, multiple conditions. Some of you guys are like, this whole three-dimensional thing, I just don't like it, so this is all pointless because we're not doing chapter 11 where all the three-dimensional stuff comes in, right? We are doing three-dimensional, just not in chapter 11. And not with 3 points. But there are other times when this whole idea of a system of equations with 3 unknowns might come in handy. And here are a few of those cases. Whoops, I need to unfreeze the screen, that was the point. Boop, there we go. In your book, there are a few sections that say, hey, this isn't quite as abstract or out there as you might think. For instance, first of all, in physics, there's this thing called the position equation. Basically, it's called free fall motion, in the sense of if you have something that's falling and all that's affecting it is gravity and its initial velocity, there's no like engine on it or anything like that that's propelling it differently. Whether you're throwing a ball up and it's coming back down, whether you're dropping an object off a cliff or off a building, etc., what's going on. This is called the free fall equation. And the free fall equation, let's just put it this way. T is time, and it's very similar to x. Isn't this really just a quadratic, guys? ax squared plus bx plus c, except there's funny stuff in each of these places. First of all, in physics, a stands for acceleration, but really it's just part of the coefficient of this squared term. V sub naught is what we call our initial velocity, and I think we've seen this one other time this year. It's in our x term coefficient, and then s sub naught is our initial position, but they're not even making us plug in accelerations, velocities, positions. They're just saying, hey, guess what? That thing that's falling, after 1 second, it's at a height of 128. After 2 seconds, it's at a height of 80. And after 3 seconds, it's at a height of 0. How possible is it for us to measure, just seeing something falling, what its acceleration is? Unless you're in physics and you know it's gravity, that could be hard. How can you look at something in the air and figure out how fast it was thrown at? I don't know. But could you take a snapshot and then measure how high it is off the ground? Take another snapshot, how high? Take another snapshot, how high? Yeah. Why do we need 3 pieces of information to figure out the equation for its position? How many unknowns do we have? How many points do we have?
6.
Well, isn't that a t that goes with an s, and a t that goes with an s, and a t that goes with an s? This is 1 point, 2 points, 3 points. How do you think we're going to use these 3 points to get these 3 unknowns? Well, let's try it out with number 48. But before I leave this page, let me show you the other 2 sections that are very similar, saying, hey, Doesn't have to be a three-dimensional vector or anything crazy like that. It could just be some random equation that has three unknowns, like, here's another much more common quadratic, right? How many unknowns do we have? So how many points do we need in order to find the equation of a parabola? How many points for a line? Why? Because we have two unknowns. How many points for a point? Just because, yeah, I know, that's funny. Anyway, but how many points for a parabola? Any 3 points you can draw one unique parabola through. So this one they're going to say, hey, we're going to give you an x, a y, an x, a y, and an x and a y. Guess what you're going to do? Plug it in 3 times. Plug in 0, 0, get an equation. Plug in 2, negative 2, get an equation. Plug in 4, 0, get an equation. All of a sudden you have 3 equations with your 3 unknowns, and you should be able to solve with row echelon form. Here's another one. How many points does it take to make a circle? Weihart, the recreational mathematician who's on YouTube, would say there's something called a circle game, where you can just draw any 3 points and try to draw the circle that goes through it. There's only one unique circle that will ever go through 3 points. So you need 3 points for a parabola, but you also only need 3 points for a circle. And why is that? If you were to take your x minus h quantity squared plus y minus k quantity squared equals r squared, and FOIL it all out and move everything to one side, you basically end up with, I know it's going to be a 1x squared plus a 1y squared, but I don't know d, and I don't know e, and I don't know f. How many unknowns? 3. So how many points do I need? 3. Anyway, let's go back to this guy and say, hey, 3 unknowns, let's solve. And it has nothing to do with 3-dimensional, not really. The free fall system is actually for 2-dimensional motion, straight up and straight down, and that's it. But I have 3 unknowns. How on earth do I use these 3 clues? I say, do I have a T-spot? And the answer is, do I have an S, not 0, a plain old S spot? All right, let's plug in. So, when S is 132, I know that T is 1. Hold on, if I plug in T is 1, isn't that just going to be 1/2 A times 1? If I plug in T is 1, isn't that just, you guys just want to call it V to make it easy, is that okay? Let's call it V to make it easy. And then there's no T there, so it's just going to be S. I guess you could make it X, Y, Z if you want, or you could call it AVS, which is what they really are. So you guys, it's your turn. What's this next equation going to be? I heard 100, it was very quiet, but 100 equals? Because you would plug in 2. 2 gets squared, which is 4. 4 over 2 is 2A. Double check. Make sense? Plug in 2, square it, 4. 4 over 2 is 2. Okay, what's the next one going to be? Plug in 2. 2V. The next one? Nothing to plug in. So just the last one. Good. I plug in. Oh, careful, not 3/2. 3 squared. 3 squared, 9/2. Does that make sense? Then plug in 3. And plug in, oh, just us. Why on earth is this type of problem and the parabola-y one and the circle-y one? I know I'm just putting "y" at the end of everything. Why is it in this section? Ultimately, you end up with how many unknowns? And how many equations? And how do you solve? Now, some of you are like, oh, this is disgusting. Okay, how do you get rid of the half? Multiply everybody by 2, both sides. How do you get rid of the half? Multiply everybody by 2. You can make it pretty, but you're just going to solve the system. Does that make sense? Just think of him as an X and him as a Y and him as a Z. Huh? Well, I was just thinking multiply everybody by 2 to make it look pretty, and then go working out your system. Does that make sense? You could work it out with the 1/2 if you want, and multiply him by -4. That would work. But some people just hate fractions that much, they'll write out a whole other system to make it gone. make them gone. Ooh, what about this guy? How on earth are you going to use all of our... It's geometry. Wait. It's geometry. Hold on. Come on, guys. It's a puzzle. Don't worry. It's not a T-proof. Although I like them. It's a puzzle. Someone tell me something that you know.
X plus Y plus Z is Y.
Exactly. Good job, Ryan. X plus Y plus Z is? There's one clue. Ooh, how many clues do I need? I have 3
2x
unknowns.
minus 7 plus Y equals 1.
I mean, these two put together have to be 180 also?
Same thing for 2x minus 7.
Oh, but these are nasty. They don't look like they're supposed to look for us to actually solve the way we've been solving. Can't we rearrange them? Yeah, could you guys do some creative stuff because you're not a computer? Yeah. And you're not trying to program right now? Yeah. But could you also make this look like the systems that we've been doing if you want to just be able to follow the systematic approach? Yeah, because you could do 2x plus y. What would you do with the 7? Go get them to join the other constants over there, right? Keep that 2x, keep that z. Move him over. What's he doing over there? 173. Oh, look. Let's go. Now do your systematic approach. The first 2, second 2. But if you want to be your whole creative, I'm going to do it my own way and just whatever. Solve. Are we done? Make sense? Ready, set? Go. Tomorrow, homework number 43 and 44. We went over the tricky ones from homework 43. And we saw just a few extra. And I think, guys, 44, it doesn't really add that much more, does it? I think it goes back and sees a few extra. If you guys want, you can grab a picture of it on your way out. Sound good? If it comes up in time. I think it would open in 10 seconds, but maybe not. E for effort. I tried. I'm gonna wait a couple more seconds, maybe it'll show up. Oh, there we go. 7.3a and 7.3b if you want it. There it is. Bye, guys.
Ryan thinks this Leon is on control. She's mean to me. That's all.
Was it until 6?
That is the nicest way I could put it. She's mean to me. That's all I can say.
Are you sure she's mean to you, or is she a strict teacher?
No, I'm so nice with her. Like I say, goodbye on the way out. I'm like, hey, this candle fall, and like I do all that stuff. Remember, but like she watering. And apply the pressure. Oh yeah, everything. That was easy. Like they said that it was already filled to like I was saying like what's that? And I wasn't even gonna say that was like, don't put that. You know, I heard that. I got this water itself. I know, but they said it was already set up, and then we did it, and then we
Hang in there, Ryan.
I'm like, oh.
Keep doing you, bud.
That was a fun one. It was fun, but the group right next to us never got it. Yeah, I know. I was like, that's the smartest group in our class couldn't get it, and it was hilarious. Overthinking.